Hey y'all, Miss Harper here for using the calculator to graph quadratics. Alright, make sure that you have your calculator with you. You can go ahead and clear that by doing a second plus 712 to get your calculator reset and ready to go. Go ahead and make sure that you have that calculator in your hand and you're not just jotting down the notes, because this can be kind of confusing if you're not following along and practicing it in your calculator as I go. Alright, so here we go. First thing, how can I graph a quadratic function? Alright, so first step is this must be y equals something, okay, whatever, x squared, blah, 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 blah. Alright, it doesn't officially have to be in standard form anymore. You just have to have everything on the other side of y equals. Second step, we want to plug into y equals in the calc, in your calculator. Alright, and then step 3, we'll go click on our graph to see the graph, and if we need to, you might need to, on some cases, you may need to zoom out if needed. Alright, and so I'll show you guys where that button is here on our third example. Alright, second thing, how can I find the vertex? Okay, well actually let's go ahead and first go into your calculator, and I want you to type in this first example at the top. It says y equals x squared plus 4x plus 2. And this is giant and I don't need it to be this size. That's better. Alright, so then I click on graph and I want to see what my graph looks like, and there he is. Alright, now I can't just blindly graph this thing onto my graph. I need to make sure that I'm plotting actual points onto there. So the first point we're going to find is our vertex. So how can I find the vertex? So first step, we're gonna use second trace. There's lots of functions in there for our calculator, and we're going to click on either the max or the min depending on what kind of graph we have. So we'll use the max if it's a negative graph, and we'll use the min if it is a positive graph. Second thing, we are going to move the cursor. This will make sense more in a second. Move cursor, it looks like this, to the left of the vertex, and then hit enter. Third step, move cursor to right of the vertex, and then hit enter. And our fourth step, it's going to ask us, we'll see this in a second, it'll say guess. And then we hit enter one more time, and it'll tell us our x and y point. Alright, so let's go ahead and try that out. So if I go back over to my calculator, and hopefully you have your graphing calculator in your hand too, pause the video as you need to. So I'm going to go to second trace, and in this case, since my graph is positive, I have a minimum. So I'm trying to find the minimum point, also our vertex. So here's what we do. So I need to scroll this little cursor right here, kind of looks like a little spider, somewhere here to the left side. So notice it's saying left bound. It wants us to put a left boundary on our vertex. So this is just somewhere to the left of your vertex, and somewhere over here, maybe right here to the right of your vertex. So your calculator, you can't see it, but look at these little lines that it's putting in on my calculator. So it's putting in a left boundary line and a right boundary line, so it knows where to look for that vertex point. And now our calculator knows, okay, so somewhere in between here, I'm going to find the lowest point. And then I hit, it says guess, and I'm going to hit enter one more time. So there it tells me my minimum is at -2, -2. Alright, so I'm going to fill that in right over here. I got -2, -2. We did decide that this was positive and I had a minimum. So I'm going to go ahead and graph that first. -2, -2. Now remember, this is also related to your axis of symmetry. So the x value from my vertex is going to be my axis of symmetry. So I'm going to go ahead and draw him in there as well. He likes to be a dashed line. All right, and so that's how we find the vertex. Let's figure out how we find our next 2 points, which are the roots. All right, so for our roots, remember the roots, these are all of the rocks. It's those x-intercepts. The rocks are the x-intercepts, so it's always, or our zeros, it's always some number for x and then 0 for y. So we kind of go through the same steps. Second, trace, 0. Now that's what we're looking for. So even if our question asks what are the roots or what are the solutions, we're still going to select the 0 function here. And then we're going to repeat the steps. So repeat left, actually let me change that. We're going to say repeat cursor steps for left and right bound. So we're going to repeat these same 2 steps over here. Actually the same 3 steps. So then 4, it's going to ask us to guess, and again we're going to hit enter. Okay, so this is where it gets kind of confusing, okay? And then we're going to get some x0 point. All right, and we have to do this twice, or however many x-intercepts you have. Must do for both x-intercepts. And then we have some special cases, and we'll talk about those. So let's talk about this next bit that's about to happen. Okay, so I have to go back into second trace. Each of these parts you have to do individually. So I'm going to do my first 0. Okay, so I'm going to look here at this x-intercept right over here, okay? So I'm going to move my cursor. Now this is kind of weird, but bear with me. So here's my x-intercept, right? It's right there on the x-axis. So I need to move it up here just to the left side of that by clicking my left arrow. And then I'm going to hit enter. And again, it's putting in that left boundary line here. And then I'm just going to move it somewhere over here to the right side and hit enter again. Now make sure that both of your little triangles are pointing towards each other. And again, yours doesn't show the boundary lines, but mine does. What it's doing here is it's finding, okay, between here and here, where is this graph crossing the x-axis? And now it says, it's asking me, do you want me to take a guess? And I'm going to say yes by hitting enter one more time. All right, now your teacher might have different rules, but for my class, we're going to round ours to 1 decimal place. So this is going to be at -3.40, and that is our first 0, and I'm going to write that in right here, -3.40. Okay, and now I have to do it again, because remember, I had a second x-intercept. I need to figure out what this one is too. So I'm going to do second trace again, and I'm going to find this 0. And now it's going to be a little different though. Okay, so it's asking me to put in a left boundary line. So a lot of times students want to go do this again. Well, that's not to the left side of it. This is to the left side of it. So see this boundary line to the left of my x-intercept, and now I'm going to move it over here to the right of my x-intercept, and then I want to hit enter one more time for it to take that guess. So again, for my class, we're going to round to 1 decimal place. This is going to round up to 0.6, -0.6, -0.60. All right, and now I can go up here and graph those 2 things. So -1, 2, 3, and a little bit more. And just between 0 and 1 was my other x-intercept. So now I have 3 points. You have to have 3 points to graph a quadratic function, and make sure that you graph it into a nice U shape. It's not a V, it is a U-shaped parabola. Okay, so kind of weird, but we're going to keep practicing that, okay? Why don't you actually pause this note video, and I want you to try example 2 on your own. This one is a pretty straightforward example. Give it your best shot. If it doesn't work out, you can pause the note video and go ask your teacher what mistakes you're making. So pause your video right now, and I'll come back with the answers. All right, if you're coming back on here, hopefully you were able to figure out example 2 on your own by completing those steps. I have the answer shown up here and also over here on my graphing calculator, so we can see they kind of look the same. And again, if you're having trouble with finding these pieces, make sure you go ask your teacher exactly how to do these pieces, and I'll explain some more here on the back too. We will cover number 3 together though. All right, so let's check out example number 3. All right, so first problem with example number 3 is it must be y equals something. So since I have this minus 7 over here, I need to get rid of it first by adding it over here. Now remember, he's a regular number, so I need to add him to my regular numbers. Now I have y equals negative 2x squared plus 8x plus 20. All right, and now we want to go ahead and plug that into our calculator. So y equals negative 2x squared plus 8x plus 20. All right, and let's go see what our graph looks like. So here he comes. Whoa, this is a giant parabola. Hopefully there you can tell that it's negative. But our first issue is I can't find my maximum. So this is that third point we made on how can I graph my quadratic. I need to zoom out. So I'm going to click zoom, and option number 3 says to zoom out. Now nothing happens until you hit enter one more time. And now my calculator has zoomed out. So now I can see my maximum. You can't do the maximum until you can see it on your screen. So I go to second trace, and now instead of a minimum, this time I'm finding my maximum point. And I do the same process where I go just somewhere to the left of my vertex, and then I move it just to the other side somewhere to the right of my vertex, and then I hit enter for it to take a guess. All right, now remember this is a calculator, it's not perfect, and I'll talk more about this in a little bit, but we can assume that this means 228. All right, it's taking its best guess there. So 228 is my vertex, 228. All right, this is negative, and we were finding our maximum. So obviously our graph isn't big enough to graph the 228, so I'm just going to do it somewhere up here, and let's pretend that that is at the point 228, which means my axis of symmetry is at x equals 2, and I'm going to go ahead and draw that in here too. Meep. Okay. So next step is to find my roots. Remember, roots are just another name for zeros. So let's go ahead and do that again. So we'll see that process. I'm actually going to zoom back in. So you can click zoom in, or zoom standard takes you back to your standard screen. And I'm just doing that, I don't know, because I want to be able to better visually see these roots. So I can tell it's somewhere, like my first one is somewhere between -1 and -2. So let's figure out what that is. Second trace. Now this time I'm finding my 0. All right, so I'm going to first move my cursor. I need to find out where he is. And here he comes. All right. So left bound. So this time I need to move it just below my axis. This is to the left. Again, I'm putting in that left boundary line, and then I'm going to move it up here just once to the right, and then I'm going to hit enter one more time for it to guess. This time I got -1.70. -1.70. Okay, so if I wanted to graph that, that's somewhere between -1 and -2, so I'm going to put them right there. Okay, now remember with our roots, if I have 2 of them, then I have to do this process 2 times. So here I go to find my other 0. Now this one, it's going to go around, and I got to keep clicking slowly. I can see it's at 2, so that means it's somewhere up here, so I got to keep clicking until I can see him again. 3, and here he comes. All right, so now it's opposite for this side. It's asking me to go to the left side. So this is up to the left of my x-intercept. And then I'm going to scroll down and hit somewhere to the right and hit enter one more time. And this time I got 5.70. 5.70. All right, so that's somewhere between 5 and 6, so 2, 3, 4, 5, and we'll say it's about right there. And now I can, draw in my beautiful parabola. All right, that is good, fun stuff. All right, and so there he is. Now go ahead and flip your note sheet over to the back because we have a few extra notes to talk about. Maybe. All right, here we go. So we got some extras. So if you want to pause your note video and maybe write down this first pink section, you can, if you need to. I'm going to go ahead and keep talking about this though. So what happens if there's no x-intercept? Sometimes we saw some graphs that didn't have any, but you need 2 more points to graph this thing. So what we're going to do is use our table to graph that. And I'll show you an example here right now. Alright, so here's an example of where I don't have any zeros. So I can still find my maximum and plot him first. You always have to plot him. Now, for the other 2 points, what I would do is go into my table by going to second graph, and I would find that vertex point, which in this case, let's see. In this case, the vertex is here at -2, -3. So I would just pick 1 point to the above it and 1 point below it. So I would plot the point maybe -4, -5, and 0, -5. Just some good wholesome numbers. 1 to the left of my vertex and then 1 to the right side of my vertex. Remember, these things are symmetrical, so I'm trying to look for ones that have some matching points like that, -4 and 0. So I would write down those 2 points and then I would plot them on my graph and continue to graph this thing. All right, next thing to talk about is remembering that our calculator isn't perfect. So we saw it on one of the examples we did earlier where I got like -2.000000001. So I'm going to just assume that it's x equals 2. Remember, the calculator is not perfect. It's taking its best guess. The other really important thing to write down is if you see this thing pop up, an E. To make a long story short, if you see that E pop up, it's trying to tell you a very tiny decimal, and we're just going to call that decimal 0. What it means, it's showing us a number so close to 0, it's just not calculating the 0. So anytime you see an E, that just means it's representing a value of 0. And that can happen for the Y value sometimes too. So anytime you see that E pop up, make it a 0, okay? Last thing that might be helpful to kind of better represent what's going on with those boundary lines is the left and right is these things right here. So whenever you're finding your vertex, remember what it's asking is telling us to put in a boundary line to the left and a boundary line to the right so it can find the lowest point here. So this is just a good visual representation of what's going on. And then the opposite happens with our zeros. Same thing. So if I'm finding this first 0 or root or solution or x-intercept, I need to put my cursor up here to the left to build in that left boundary line, build in that right boundary line so it knows I'm talking about this x-intercept right here. And then the opposite happens whenever I go to find the other x-intercept. All right, whenever I go to find this one, well, to the left boundary line would be on this side, the bottom side of the parabola, and then the right would be on the top side of the parabola. So make sure that you're moving that cursor to the left and right of the x-intercept as needed. If you need more help with this, just go see your teacher and we can better help you with this part.